Right, guys, I am a bit late today to the YouTube live, so I'm going to give you a couple of minutes to join in. So today's session, we're going to be looking at magnets. We're on session 11. This is Learn with Sid on YouTube, and we're having a session on science today. So we're going to be looking at magnets. So I'm going to share my screen in a second, and I'm going to check who is signed in as well. So let's first of all just make sure that I've got everything, all my volume switched off. I don't want that. Yep, that's fine. Right, I'm going to share my screen. I'm going to share my table so you guys can see what I'm doing. So in today's session, you're going to be needing a couple of things. Where is my screen? Hold on a second, guys. You're going to be needing some paper. So we've got some paper over here. You're going to need a fridge magnet. So I've got a fridge magnet over here. You're also going to need some felt tip pens and a pencil like what we normally use. So get all those things ready. And I'm going to be just sharing my screen. Yep, I've got it now. Excellent. Okay, and if you're watching live, then give me a shout out on YouTube. I know I'm 5 minutes late, but I'm here now, so let's make a start. Okay, so I've got a fridge magnet over here that I'm going to be using in a second. I've also got some paper, I've got a pencil, and my felt tip pens are over here. So I'm going to be needing all of this stuff for today's session. So we're looking at magnets. Now, magnets have they've got a magnetic field. We can't see it, but we can obviously feel it. So if you put two magnets together, you will feel either a repulsion or an attraction. So we've got magnets in lots of applications. We've got fridge magnets. We've got magnets where we have what else do we use magnets for? If you've got any suggestions, let me know. So I know fridge magnets is one that's common, and most of you will have some fridge magnets at home. So what we're going to be doing today is looking at a bar magnet, and we're going to look at a fridge magnet. So this is a magnet that one of the kids gave to me, which I keep on my fridge. So we're going to be using that as well. So first of all, let's have a look at a bar magnet and how it works. So a bar magnet, you would have seen these at schools. You have a long bar that's divided up into two pieces, and each of those pieces is labeled. Okay, so you've got a bar magnet which is labeled. One's going to be north and one's going to be south. So the red one is our north pole. So I'm going to be colouring in this side of the magnet. And if you've got a bar magnet at home, brilliant, you can use that for your experiments that we're going to be doing a bit later. Okay, so this is my north pole. I'm going to write N over here. And then on the other side is going to be our south pole. And we're going to colour that in blue. So I'm going to do this blue, but I'm going to write an S there. So when I colour it in, you can still see that S. So bubble writing S. So this is a bar magnet. And we're going to have a look at the magnetic field around a bar magnet and how it looks like. And I love doing this experiment with iron filings because you can actually see the pattern that you're creating. So let's use a pencil for this. We're going to create the shape of the magnetic field around this. So what happens here is you have lines coming out of north. Okay, so on the edges, you've got straight lines. Here you could have straight lines. These eventually are going to curve at the edges, but we're going to leave them as straight. Then you've got another line which comes all the way across to the other side. Okay, we're going to do that the same on the other side, all the way across and to the other side. And I'm going to put two lines here. So you've got two like that. And this shows you how the magnetic field is going to be like. So at these points, the magnet is really weak. Okay, there's hardly any magnetic field there. At these points, the edges, that's where the magnet is going to be the strongest. Okay, so these edges, the north and the south pole here, are the places where your magnet is going to be the most strongest. So I'm just going to see who signed in and give you guys a shout out. We've got Amina is watching, Umeza, and who is it, Hussein joining you. And we've got UB5 is joining in today. Brilliant. We've got loads of people watching. So your magnets, we're going to draw your bar magnet like this, and we're going to be drawing the magnetic field lines. Now, once you've drawn them in pencil, we can go over them in a felt tip or even a pen. So let me see if I can find a black. I found a black. So now I'm going to start putting in the arrows of our magnetic field lines. And the arrows always go from north to south. So these arrows are going from north to south. It's always like that. So here, I'm going to draw another magnetic line from north to south. I'm going to do one on the other side. From north again to the south. Let's draw that again. From the north, so arrow coming out of the north and going into the south, okay? And then if you see, none of those lines overlap. The lines can't overlap with each other. So here, and they don't cross over either. So here, the lines are going to go towards the south, and then on this side, they're coming out of the north, okay? And all of those lines will never ever overlap. Field lines don't overlap, okay? So this here is a bar magnet, so I'm going to label that as a bar magnet. Now, we talked about the application of magnets in fridge magnets, but you also have magnets in a compass. So let's draw here a compass. I'm going to draw here a compass, and a compass has a needle which points to north. So I'm going to write north, east, south, west. You could color this compass in and make it nice and exciting, okay? So I'm going to put here a compass. Now, how does that compass work? It needs to have a magnetic field for it to point towards north. So if we now have a look at planet Earth is basically a huge, massive bar magnet. So in here, we've got a bar magnet. Now, we call this the North Pole. Okay, we call it the North Pole, but it's not the north-seeking magnet there. The magnetic field here is actually the south. So what we have, the bar magnet in here, is going to look like, if we were to draw this as a bar magnet, you'd have your south up here, you'd have your north down here. Now your North Pole is here, and your South Pole is here on planet Earth. But remember, your arrows are always going from north to south, okay? So this arrow on our compass is actually pointing to the south magnet in the planet Earth, okay? So the planet Earth is like, it seems like it has a huge magnet in it, okay? And this is what it would be looking like. So I'm just looking at who else is watching. So if you guys are watching, give me a shout out and let me know that you're watching and you're following. So we're going to be drawing now the magnetic field lines on our Earth. So here, first of all, let's draw some islands on our Earth. You can color this in later. Right, now to draw the magnetic field lines, again, we're coming out of the north and we're going towards the south. Okay, so we're coming out of the north and we're going towards the south. So your arrows are going to go this way, which is why your north arrow on your compass points towards the south, because all the arrows point towards planet Earth. Okay, right, so you can color this in later. I'm going to be making this look like a proper compass a bit later as well. Right, now our experiment. So what I want you guys to do is an experiment in the house where you use your fridge magnet, or if you've got a bar magnet, you can use that as well. And we're going to find out which objects are magnetic and which aren't. Okay, so here we're going to have magnetic, not magnetic. So draw a little table and we're going to be looking at some data. Okay, so these are going to be my objects over here. So I might want to start off with, let's start off with the table. So I'm going to write table over here. If you want to, you can draw the pictures rather than actually writing the words. Now I'm going to see if the table's magnetic, I don't feel a magnetic pull. So this is not magnetic. So I'm going to put a tick here. Okay, so that's my table done. Then I might look at the radiator. So let's write radiator over here. Make it nice and colorful as well, guys. So radiator, so I'm going to take this bar magnet and I'm going to put it on my radiator. It stays on my radiator. So I've got a radiator behind me, so it sticks to my radiator. So this means the radiator is magnetic. Okay, and keep going and make a huge table of all the different objects that you guys have tested at home. And let me know whether you find lots of magnetic materials at home. Okay, so submit in your drawings. I'm going to write over here my name. My name's Sid. And today's session is Science with Sid. So write that in, hashtag Science with Sid. Submit in your drawings by 6 p.m. today. And then they'll be included in the submission video a bit later on today. Make it all nice and colorful. I want you to make this really nice and colorful so you can refer back to it in the future when you come to doing more stuff on magnets. Okay, so thank you guys for listening. Tomorrow we're back to art. So tomorrow's YouTube live session at 3:30 is going to be on art. So we'll get you guys to get some materials together for that and we'll take part. I look forward to seeing you guys. So I'll see you tomorrow at 3:30. Bye, guys. Bye.